Friends, today I am going to discuss about the chapter amines by some problems. So let us start. Before we start the problems, I would like to discuss about the two general notes. That is, orthosubstituted aromatic amines are usually weaker bases than aniline. This is the first one. And among the aliphatic methylamines, the order of basic strength in aqueous solution is 2 degree amine, greater than 3 degree amine, and greater than 1 degree amine, and so on. Ammonium. This is the basicity order in aqueous medium. Right. So let us start question number 1. Question number 1 here says that you have to arrange the given compound according to the criteria given in the bracket. So first one says basicity in the aqueous medium. So here as we learn from this note 2 that in aqueous medium the 2 degree amine is more basic than 3 degree amine. So this is right. First one is right. And second one says that basicity in aqueous medium, that this is 1 degree amine and this is 3 degree amine. So this is also correct. This is also correct because here 1 degree and here 3 degree greater than. So this one also correct. And number C, it is also correct. As you see that N is means ammonia, here nitrogen is directly connected to the one ethyl group and one methyl group, and here nitrogen is connected to one only carbon. So here plus I effect is more compared to this compound. So here nitrogen has higher electron density than this nitrogen. So this one has more basicity. And then D, you can see that here nitrogen number 3, 2, 1. In nitrogen number 3 here only one resonance is possible, but here lone pair can go in this side also and this side also, 2 resonance. So by this logic N3 means the position number 3 nitrogen is more basic than position number 1. But in aqueous solution it is actually the opposite or the reverse. The position number 1 is more basic than position number 3. Then problem number 2. Before doing problem number 2 you have to learn some chemical reaction to remember. Alkyl amine reacts with chemy&4 gives aldehyde. 2 degree amine reacts with H2SO5 giving oxime. R3N react with H2SO5 giving R3NO, and R3CnH2 react with H2SO5 or chemy&4 giving R3CNO2. This is nitro. So according to the question here, RNH2, so which one will form? This one, aldehyde, and R2NH, which one will form? This oxime only. R3N H2SO5, this one, and this last one is nitro. So option number A. The next question says that the compound which is most reactive towards diazo coupling with benzene diazonium chloride is. Here nitrobenzene is given, here methoxy benzene is given, here aniline is given, here phenol is given. As here about medium is not told, so it is a neutral medium, so you can say that in neutral medium this reaction is applicable, that benzene diazonium chloride reacts with aniline in neutral medium giving this compound. diazonium it formed. So this one is will correct answer. But in this one is acidic medium and this one is basic medium. If in basic medium, then OH will be formed, right? Then this one, 3-degree butyl alcohol can be converted into 3-degree butyl amine conveniently by CH3. This one is 3-degree butyl alcohol reacts with HCN. Here mechanism is that the lone pair oxygen donates H plus proton, accepted proton. Then here positive charge comes over the oxygen. Then this bond pair breaks and positive charge comes over carbon. Then this lone pair above the nitrogen attacks the positive carbon and forms isocyanate. And after reacting H2SO4, it forms amine. So this one will be the correct option. And option A is wrong because if this alcohol reacts with PCl5 and it will form 3-degree butyl chloride. But when it will react with NaOH2, so that time as chlorine is poor leaving group, so reaction is very slow or not possible, not convenient. I can say that only. Not possible is not convenient. So this one also not possible and this one also not possible, same thing. And now all of this though not possible. The next question, NaNO2 HCl causes diazotization of aniline and results in the formation of diazonium salt. Identify X and Y in the following reaction sequence. So benzene diazonium chloride, here 2 X phenol, after reacting with phenol gives X, and after reacting with benzene and in the medium NaOH give Y. So first see, this one is benzene diazonium chloride plus phenol gives this compound, this one, right? And when it reacts with benzene in the medium NaOH gives this one into NaCl and diphenyl group, this one, right? So then next question, the correct order of basicity of the following compounds is CH3CNH2 and this compound and this compound and this compound are the options. So as you can see that here C is attached to the 2 amine group, so there is 2 lone pair of each nitrogen, so this one is more basic, means more basic in these options, among the options. And after that 3 will come because it has more plus I effect, so density above or over the nitrogen is more, electron density. Then 1 means 2 will come, as this one is not in resonance or something like that. Then number 4, this one is in resonance, lone pair. So basicity in this order, 1, then 3, then 2, then 4. Number 20 not this one, sorry. Next question, this one is the compound which, and this one is H2SO4, which tells us about the Beckmann rearrangement. In Beckmann rearrangement, this OH here cuts and this one bond here cuts, then this OH comes here as carbonyl group and this methyl group transfers to nitrogen, this one. This here is one mechanism is there, but I am not telling that because it will take some time. So you can check in net or in book Beckmann's rearrangement. Then the next question is, arrange the following compound in decreasing order of boiling point. Here you can see that this one is not decreasing, this is increasing, because here sign is as the molar mass increases, so the boiling point also increases. So this one will be increasing. So this one, option A will be correct, because as the molar mass increases, so boiling point also increases, right? Then next question. An organic compound C3H7NO2 on reduction gives a compound A having molecular formula C3H9N. Another compound B on heating with Br2 plus KOH from the compound A. Compound A and B are respectively. Here a compound given C3H7NO2 on reduction gives A, means that here as NO2 is there, after reduction it will form NH2, right? Then compounds A is C3H7NH2, and another compound you have to find that B, which on reacting with Br2KOH gives A, means C3H7NH2. So this is the reagent of Hofmann's degradation reaction. So we know that when amide reacts with this Hofmann degradation reagent, it makes amine. So one CO carbonyl group will add between this. So the compound A will be amine and compound B will be amide. So the option B is correct. Then the next question. Dichlorocarbene does not form as an intermediate in this reaction. This question says that in which of the following the dichlorocarbene does not intermediate does not forms. So in option A, we can see that the reactant implies it is the reactants of Riemann-Tiemann reaction, and in Riemann-Tiemann reaction, as CH3KOH is there, so it will definitely form the dichlorocarbene intermediate. So this one is not the answer. The next question is ethylamine plus CH3Cl3 plus KOH. Here also CH3KOH is there. It is the main ingredient to formation of dichlorocarbene. So this one also not possible. Last one, here also main ingredient of formation of carbene, as I have here written the mechanism also, that H and OH of KOH here react, means remove as water, and this bond breaks and forms KCl and this dichlorocarbene, right? So this one also not possible, so the only answer will be this one. These all are a single correct option. Then the next question says that in the following reaction the reactants A, B and C are C2H5NH2 plus A, giving C2H5N double bond CH single bond C, C6H5 plus H2O. Second reaction says urea plus B, giving NH2 NHCO NH2 plus NH3. Third, C2H5NH2 plus C, giving C2H5Cl plus H2O plus N2. So we have to identify the products or the reactants A, B and C. I have to find the compounds. So first reaction C2H5NH2 plus A, C2H5N C6H5 plus H2O. So this one. Then according to the options we can see that aldehydes is the first option of A. So as C6H5 is there, so we can take benzaldehyde as an option and see that C2H5NH2 and reacting with C6 benzaldehyde, then this 2H and 1O remove as a water and forms this product. Elimination happens here. elimination of water, then formation of this product is formed. Then option 2 is that here this NH2, here N minus and here H plus, this N minus attacks this carbonyl group CO, and this bond makes as lone pair above the oxygen, and after that this electron lone pair come back to this bond, make bond, and this bond breaks and form this product, the given product. So the compound B is hydrogen. And last option number 3 is C2H5NH2 plus NOCl. So break the NOCl in between NO plus and Cl minus, and then break this one as here plus and minus. So my plus with minus, then C2H5 plus Cl minus and C2H5Cl plus N2 and H2. So the correct option is this one. Next, this one we discussed earlier. Identify the product of the following reaction. So this one will be this ethyl NH2 and then ClCO Me. Then this will HCl will eliminate from here, and this one will form. So this one will be the answer. So next question is identify or which of the following is the strongest base. So you can see that here the lone pairs are in resonance, and here also in resonance, and here also resonance, but here resonance does not take place. So this one is more basic, or the strongest base. Next question, an organic compound with the formula C3H5N on hydrolysis forms an acid which reduces Fehling solution. The compound can be, so by trying all the compound given in the options, we have to see ether nitrile. Hydrolysis of ether nitrile gives a ketone, and ketone does not give Fehling test. So A is not possible. Then isocyanoethane. When isocyanoethane is hydrolyzed, then it forms a aldehyde which gives formaldehyde test. And after the ethoxyethane, when reacts with H2 or hydrolysis, then it forms 2 moles of C2H5OH. Alcohol forms. So as Fehling test give the aldehyde test, so option B is correct. And this one is nitrile, same as first one, aldehyde ketonyl form. Then the last question says that a hydrocarbon A C4H8 on reaction with HCl give a compound B C4H9Cl, which on reaction with 1 mole of ammonia gives a compound C C4H11N. On reacting with NaNO2 and HCl followed by the treatment with water, compound C yields an optically active alcohol D. Ozonolysis of A gives 2 moles of acetaldehyde. The structure of compound C is, so we can take the last statement to get into the answer. It says that ozonolysis of A gives 2 moles of acetaldehyde. We can easily get the compound A. How? That we know that if in ozonolysis we break the double bond, and this way we break the double bond, and this way O, and here also O, then 2 acetaldehyde will form, right? So the compound A is this one, on a 2 butene, then reacting with HCl it forms these ones. This it's a addition reaction, so H will add here and Cl, same reaction, symmetric. This one is symmetric, so Cl and H can add anywhere. So after that, reacting with ammonia, and the H will attack here and ammonia and NH2 will add here. So the compound is this one, is the compound C. Right, finished.